What if the ice sheets of Antarctica are not just melting into rising seas but triggering a chain reaction that could unleash hundreds of volcanoes lying dormant beneath the world's coldest continent? Imagine a place where beneath miles of solid ice, fire brews in silence, waiting for the perfect moment to break through. Antarctica's melting ice could spark volcanic eruptions powerful enough to reshape not just the frozen landscape but the entire planet's climate and coastlines. Few people realize that the Antarctic ice holds a threat far beyond rising sea levels. It's the explosive volcanic activity that could be awakened as the ice disappears. In the next few minutes, we will uncover how these hidden volcanoes were discovered, why the melting ice could set them off, and what this means for the world's coastal cities, global weather patterns, and even air travel. Stay with us to see why scientists are racing to understand this secret volcanic threat under the Antarctic ice. What lies beneath the volcanoes under Antarctica? When most people think of volcanoes, they picture fiery mountains in tropical islands or along the Ring of Fire in the Pacific. But one of the world's largest volcanic regions lies deep under the vast frozen sheets of Antarctica. Scientists have so far identified more than 138 volcanoes hidden beneath the Antarctic ice, and experts believe there could be many more waiting to be found. This makes Antarctica the largest volcanic region on Earth by some estimates, yet one of the least understood. The discovery of these volcanoes didn't happen overnight. It began with radar mapping missions, as researchers beamed signals through miles of solid ice to detect unusual shapes and heat signatures far below. Seismic data also revealed tremors that didn't match normal glacial movements but hinted at the rumblings of volcanic activity buried in darkness for millions of years. One of the most fascinating examples is Mount Erebus, the southernmost active volcano on the planet. Its lava lake bubbles constantly just a few miles from the McMurdo research station, reminding scientists and explorers that Antarctica is not just a frozen wasteland but a land of fire and ice. And Mount Erebus is not alone. Studies have found volcanic peaks hidden beneath the West Antarctic ice sheet, some standing nearly 12,000 feet tall, cloaked entirely by ice. These peaks are not dead relics either. Some show signs of activity, with geothermal heat melting the base of glaciers from below, creating massive lakes of water trapped under the ice. There is growing debate among geologists about just how many volcanoes may be hidden still. Some estimates suggest there could be hundreds more, forming a chain of volcanic features stretching across West Antarctica, waiting to be confirmed as technology improves. But what happens when the ice that weighs them down starts to disappear? Many scientists argue that the sheer weight of the ice acts like a lid, holding back the pressure building in magma chambers below. As Antarctica's melting ice continues to vanish at an alarming rate, this hidden world of volcanoes could awaken in ways that few people are prepared for. This raises an urgent question. Could melting ice be the fuse that lights these ancient giants once again? Why Antarctica's ice is melting so fast? Antarctica, once thought untouchable by the forces of climate change, is now one of the most rapidly warming regions on the planet. Over the past 50 years, parts of the West Antarctic ice sheet have seen temperatures climb by more than 2.5 degrees Celsius, far exceeding the global average. Scientists have sounded the alarm as satellite imagery and on-the-ground measurements reveal that the ice shelves holding back massive glaciers are thinning and breaking apart. In 2020, Antarctica recorded a temperature spike that shocked researchers when the thermometer hit more than 20 degrees Celsius near the northern tip of the peninsula, an unprecedented high for a continent known for its brutal sub-zero climate. This warming trend is not a fluke but a clear signal of accelerating climate change. The West Antarctic ice sheet is particularly unstable because much of it sits on bedrock below sea level, making it extremely vulnerable to ocean warming from beneath. Warmer ocean currents creep under the ice shelves, melting them from below and loosening the grip on inland glaciers. Once these floating ice shelves are weakened, the glaciers behind them can slip faster into the sea, adding billions of tons of fresh water to global sea levels every year. What makes this even more alarming is how meltwater influences the geology beneath. As the ice melts, water seeps down through cracks and channels, reaching the bedrock far below. This water acts as a natural lubricant, reducing friction between the ice and the rock. In volcanic regions like West Antarctica, this meltwater can find its way into volcanic fissures, adding pressure to magma chambers and potentially destabilizing them. Scientists have pointed to similar mechanisms in other glaciated volcanic regions, where the interaction of meltwater, heat, and the Earth's crust has set the stage for eruptions. Recent studies project that if greenhouse gas emissions continue unchecked, the West Antarctic ice sheet could pass a tipping point within this century. Should that happen, the runaway ice loss would be nearly impossible to stop, and the hidden volcanoes lying dormant could suddenly find the crust above them much lighter than before. The link between climate change and volcanic risk in Antarctica is a sobering reminder that Earth's systems are more interconnected than we ever imagined. As each year passes and temperatures continue to climb, the icy barrier that has contained these fiery forces grows thinner, setting the stage for a scenario that could echo the dramatic geologic shifts of Earth's distant past. How melting ice triggers volcanic eruption. Understanding how Antarctica's melting ice could spark volcanic eruptions means looking back at a powerful process called isostatic rebound. Imagine the Earth's crust as a giant sponge, compressed under the immense weight of glaciers for thousands of years. When that weight is lifted, the crust begins to rise, flex, and crack in response. This lifting effect doesn't happen instantly. It can take centuries, but it has profound consequences for the magma trapped below. As the pressure on magma chambers drops, gases that were once contained start to expand, making eruptions far more likely. This idea is not just theory. Earth's history is filled with examples showing how retreating glaciers have awakened volcanoes. In Iceland, after the last ice age ended around 12,000 years ago, the island experienced a surge in volcanic activity. Studies show that the volume of lava erupted increased 30-fold in some regions as the ice retreated. The same trend was observed in Alaska and parts of western Canada. In Alaska's Wrangell Mountains, the end of the last glacial period brought volcanic outbursts that reshaped entire landscapes. Researchers believe this same mechanism could be at play beneath Antarctica's thick ice sheets today. Modern computer models simulate how quickly the crust could respond as the ice disappears. Some estimates suggest that as Antarctica's melting ice continues to vanish, uplift could occur at rates of up to 40 mm per year in some regions, enough to stress fault lines and volcanic systems beneath the surface. These models also point out that the geothermal heat under West Antarctica is already unusually high because of a mantle plume discovered near Marie Byrd Land. This means that some volcanoes may already be closer to eruption than previously believed, just waiting for the final push that a lighter crust could deliver. Many geologists now warn that the risk is not confined to slow geologic timeframes. Dr. Stefan Gruber, an expert on glacial geology, explains that while the process can take thousands of years, localized uplift can trigger sudden releases of built-up pressure. He points out that the underestimated interaction between climate change and geological hazards could have consequences that science is only beginning to grasp. This insight is echoed by Dr. John Smelly, one of the world's leading volcanologists studying the Antarctic region. He argues that our understanding of subglacial volcanic risk is still in its infancy and that surprises are almost guaranteed. Some skeptics argue that any potential eruptions would be minor and pose little threat to the global climate. But history shows us that small local eruptions can sometimes cascade into larger events when multiple volcanoes awaken together. In Antarctica, with its vast chain of hidden peaks, the chain reaction could release massive amounts of ash into the atmosphere, disrupt global weather patterns, and accelerate ice melt further. The paradox is chilling. The more the ice melts, the more pressure is lifted from these ancient volcanoes, and the more likely they are to awaken, melting even more ice in return. This feedback loop could be one of the least understood but most dangerous climate tipping points lurking beneath the frozen surface. Hidden threat: the supervolcano risk. When people hear the word supervolcano, they often think of Yellowstone or the Toba eruption thousands of years ago, but few realize that some scientists believe parts of West Antarctica could hide volcanic systems powerful enough to rival those legendary eruptions. The idea of a hidden Antarctic supervolcano has captured the imagination of geologists because of unusual signs deep beneath the ice. One region of particular interest is Marie Byrd Land, a vast area with a massive mantle plume pushing heat toward the surface. This hotspot acts like a giant blowtorch beneath the West Antarctic ice sheet, melting the base of the ice and creating subglacial lakes that can drain and refill suddenly, hinting at geothermal activity far greater than once believed. One case that stands out is Mount Takahe, an ancient shield volcano that towers above the surrounding landscape, buried under miles of ice. Some researchers argue that the volcanic system connected to Mount Takahe and the broader Marie Byrd Land region could form a complex capable of releasing enough ash and gas to impact global temperatures if triggered on a large scale. The evidence is still debated, but deep ice cores taken from surrounding areas have revealed ash layers that suggest massive eruptions have occurred here before, possibly during past warm periods when the ice sheets were thinner. If even part of this hidden volcanic network were to erupt explosively, the consequences would not stop at Antarctica's icy shores. Ash plumes could circle the globe, blocking sunlight and disrupting weather patterns for months or even years. Sulfur dioxide released into the atmosphere would contribute to temporary cooling in some regions, creating the strange possibility that melting ice could unleash an eruption that briefly counters global warming before fueling it all over again. As the debate continues, one thing is clear: the risk of a hidden Antarctic supervolcano shows how much we still have to learn about the forces shaping our climate from below. If eruptions happen, global consequences. It is easy to think that a volcanic eruption hidden under miles of Antarctic ice would stay isolated in the far south, but the reality could be far more disruptive than most people imagine. If multiple volcanoes were to awaken as Antarctica's melting ice retreats, the immediate effects would ripple across the planet. Under the ice, heat and pressure could generate explosive eruptions that blast ash clouds high into the atmosphere, carried by winds to continents thousands of miles away. This ash would not only darken skies but also clog airplane engines, forcing the rerouting or grounding of flights on a massive scale. The 2010 Eyjafjallajökull eruption in Iceland shut down European air traffic for days with far less ash than a cluster of Antarctic volcanoes could produce. Another serious consequence of an Antarctic volcanic chain reaction is the potential for tsunamis. As ice shelves fracture and collapse into the ocean during an eruption, massive waves could travel across the Southern Ocean, reaching distant coastlines with little warning. Some scientists argue that undersea landslides triggered by volcanic tremors could make these tsunamis even more unpredictable and destructive. The threat would not be limited to coastal erosion but could inundate communities, ports, and fragile ecosystems that are already struggling to adapt to rising sea levels. Speaking of sea levels, the feedback loop between volcanic eruptions and ice melt could push coastal cities into a new era of chronic flooding. Ash deposited on the remaining ice sheets would darken their surface, causing them to absorb more sunlight and melt faster. As more meltwater flows into the ocean, low-lying cities like New York, London, and Shanghai could face an acceleration of the flooding they already fear from climate change alone. For island nations in the Pacific and Indian Oceans, this could mean the difference between survival and disappearance beneath the waves. The economic and ecological impacts of such an event would be staggering. Shipping routes could be thrown into chaos by floating icebergs and unpredictable weather. Fisheries could collapse as marine food webs are disrupted by sudden temperature shifts and ash fallouts. Agriculture could suffer if global temperatures drop temporarily, shortening growing seasons in regions that depend on stable climate conditions. Insurance costs for coastal infrastructure would soar as entire communities become increasingly uninsurable. It is a sobering scenario that makes clear how interconnected the world is with the icy volcanic secrets buried beneath Antarctica's vast white expanse. The scientific debate: real risk or hyped fear? For every scientist warning that Antarctica's melting ice could awaken a chain of hidden volcanoes, there is another expert urging caution about overhyping the threat. Some geologists argue that while the link between ice loss and volcanic activity is well documented in places like Iceland and Alaska, the unique geology of Antarctica makes large-scale eruptions less likely than fear-based headlines suggest. They point out that the vast thickness of the East Antarctic ice sheet acts as a stabilizing force, and that the region's volcanic systems may not respond as dramatically or as quickly as models predict. Yet the debate often runs deeper than pure science. Critics of doomsday scenarios claim that dramatic projections attract more research funding and media attention, shaping a narrative that is difficult to challenge once it gains momentum. They argue that cautious estimates, which suggest only isolated volcanic events, rarely make the news but may be closer to reality. On the other hand, proponents of the more alarming view insist that underestimating the risk is far more dangerous. With climate change accelerating, they say, ignoring even low-probability, high-impact threats is a gamble the world cannot afford. As the debate continues, the real risk may lie in the uncertainty itself, and in how prepared we choose to be for surprises beneath the melting Antarctic ice. Case studies, lessons from past climate volcano-linked history leaves clues about what happens when ice and fire collide. At the end of the last ice age, vast glaciers retreated from North America and Europe, and volcanic activity surged across the globe. This pattern is clearest in Iceland, where the relationship between glaciers and eruptions is like a time lapse of Earth's geological heartbeat. As thick ice caps vanished, the land beneath rose, stress shifted, and dormant volcanoes burst back to life, reshaping the island's rugged terrain. In Alaska, a similar story played out. When massive ice sheets melted thousands of years ago, the sudden release of pressure unleashed explosive eruptions that scattered ash for hundreds of miles. These events show that the Earth's crust responds to rapid deglaciation in powerful and sometimes unexpected ways. Even today, Iceland's volcanologists watch glacier movements closely, knowing that the melt season can influence volcanic activity beneath the surface. These lessons from the past remind us that Earth's natural systems are deeply connected. They offer a stark example of how melting ice can set off forces that seemed frozen in time. If Antarctica's hidden volcanoes are anything like those in Iceland or Alaska, then the next few decades of warming could reveal a landscape that is not just thawing but awakening in ways that could echo through the world's climate and coastlines. What the future holds. Are we ready? As the science around Antarctica's volcanic risk grows, so does the question of whether humanity is ready for whatever lies beneath the melting ice. Monitoring the world's most remote volcanic region is no easy task. Researchers are deploying seismic sensors deep under the ice to detect subtle tremors that might signal magma on the move. New satellite systems track the slightest shifts in the ice sheets and the land below, giving scientists valuable clues about how the crust responds as glaciers vanish. International collaboration has become critical. Countries with research bases in Antarctica are sharing data like never before, trying to piece together a clear picture of the continent's hidden volcanic systems. But some experts worry that political tensions and limited funding could leave blind spots just when more eyes are needed most. Technology offers some hope. Advances in remote sensing, ice-penetrating radar, and real-time monitoring mean that warning systems could give at least some notice if a major eruption threatens to break through. Still, predicting volcanic eruptions remains one of the greatest challenges in Earth science, and the added complexity of ice-covered volcanoes makes the task even harder. In the end, it is not just a scientific question but a test of how prepared we are to handle surprises from a changing planet. Are we ready to face the possibility that Antarctica's melting ice could spark a chain of events no one saw coming? Do you think this risk is real or just another overblown climate fear? Let us know in the comments below, and keep watching, because the story beneath the ice is far from over.